Okay. I took this slide from the Dr. Shahrul. If you look at the island, you can download the slide from there. Okay, it's basically the same. All right, actually the slide whether doesn't the slide should is the same. It's just like the cosmetic changes happen to some of the slide, but the content will be the same. So if you download any slide from other lecturers, the content will be the same because it will take from the same textbook. All right. Okay, all right. Okay, guys. Right. So we already at 10 a.m. So I wish we can start the class today. All right. So, all right. Before that, I would like to say Assalamualaikum and very good day to all of you. And welcome back to our class, the MEC531 on the lecture side. All right. Okay. Before we begin, all right, I think is okay. The most common thing we should do is we should recite a doa, all right, so that you can have the keberkatan dalam pelajaran kita hari ini ya. So sama-samalah kita baca Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahirabbil Ar-Rahmanir-Rahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Alright guys. So last week awak dengan Dr. Azim, so I think he's already finished all about the design of mechanical joint. So I'm sure that, all right, you are, I'm sure that you have some knowledge about it. All right. So, okay, this week and the next following week, you're going to be with me. All right. So we are going to discuss about the power transmission elements. All right. So how to design it. Okay, so I believe that most of you very familiar with this topic, which is the gears, right? So you have seen it before, right? Probably from your bicycle or, from the toys for your motorbike and so on. All right. And the number 2 is about the shaft. So if you have the gears, usually they are connected with the shaft. All right. So this is a topic will be covered within 2 weeks lecture. All right. So so however, okay, for this chapter 4, okay, much attention will be given on the gears. All right. Shaft ni is very simple tak ada apa sangat. Tak banyak sangat dia punya kerenah dia, but the gears ni banyak jugalah. So this chapter is quite technical. Alright, so I do hopefully that you have the textbook with you, which is the Shigley's mechanical design. Doesn't matter that which version do you have. Right, mine is actually the got it. The 10th edition of the uh, of the what 10th edition, eh? So probably now the latest should be 12. So doesn't matter whether either it is in form of the PDF or in form of the physical book, because some of the table we need to refer in this book, and I believe that you will need this book because you are going to have your test as well, so it's better to have it. Okay, all right. Okay, how many are we here? Okay, we have now in our class around 102. So supposed to be we have around 200, eh. So kalau ada kawan-kawan yang masih tak masuk lagi, tolong ajak dia, eh. Alright. So alright. Okay, alright. Let's begin with the slide. Okay. Just a moment. Okay, so for the chapter, I'm going to cover this week about the gears, but saya tak akan finish it. Okay, I'm not going to finish it because gear is macam banyak dia punya, especially banyak sangat dia punya calculation, especially how to determine the force, okay, the terminology. So dia banyak, so I will not finish it. So I will bring it into the following week. Okay, Shafni is very simple. I think within 10 or 15 minutes I can finish it. There's not much calculation on it. All right, let's begin with the first slide. Okay, so introduction. All right. Okay, so what is a gear? Okay, if you look at the statement here, it says that the use of the gear is to transmit the power, okay, for one shaft to another shaft. All right, that is the reason we have the gears. All right, so that is the reason we use gears. Okay, all right, so when you talk about power, about gears, so kita cakap tentang dua benda lah. Pertama, we talk about the speed, okay, which is the how fast it's rotate, and the second one is obviously is about the torque. Okay, so torque and the speed actually is the basic thing, so we can reduce or increase the speed or the torque. So I think you have familiar the use of the gear, okay, because you ride a bicycle before, yeah, which is, you know, the mountain bike or the ataupun satu lagi tu panggil apa, saya lupa dah, road bike. Okay, so you know that if you want, go to the to the hill, you need to have a very low gear, which is you need a lot of torque, so that you can still move on. And somehow for reason, if you are in the straight load, okay, you need a very high speed, so you need to go to the very high gear, right? So the other things about the use of the gear is to transmit power around corners and over the distance. Okay, so what does mean around the corners is means that, for example, that if the orang kata the orientation of the you need to transmit over the distance. Okay, that's the first thing, over the distance. Sometimes you have the engine the other side, you have the call it the tire the other side, so this is over the distance. The other is around the corners. Okay, means that sometimes the application is for example, kalau engine tu bagi on the right side, sometimes you want to change the orientation of the motion, you need to to change it. So that is the use of the gear. All right, so and number 4, all right, so if you look at the slide, we want to efficiency, reliability, accuracy, smoothness, quiet operation. All right, this is the generally what we as engineer want. Okay, all right. So tak ada soalan, all right, this is a straightforward, I think you can read it. All right, so let's talk about type of gear. Okay, so we have a lot of gears, okay, in the market. Okay, depend on the application, right? So what the common gear that we use, we can have the spur gear, right? We have the helical gears, we have the beaver gears, and we have the worm gears. This is normal, all right? So there are a lot of it. Okay, tapi macam but this four of gears is mentioned inside the Shigley textbook. Alright. So so what is a spur gear for? Okay, sebenarnya spur gear ni untuk dia punya karakteristik is okay, the gear are aligned parallel each other. Okay, maksudnya shaft lah. We talk about the shaft. So they are aligned each other. So the spur gear and the helical gears are used in a parallel shaft. Alright. So if you have a perpendicular shaft, which is they are oriented 90 degrees of each other, and they are intersecting, we call it as we need a beaver gear and the worm gears. Alright. Tak apa. Kalau awak tak nampak bayang lagi, tak apa. Saya akan tunjukkan what call it, the example of it later on. The next slide. Okay. Alright. So when you talk about gears, okay, we as engineer, we do not need to design the gears. Alright. So the standard is there. Okay. We call it as the ACMA, which is stand for the American Gear Manufacturing Association. So this standard has defined everything about it, how to calculate and blah blah blah, what is the size and everything about it. They also have a other standard. Okay. Alright. There's a European standard. But normally, since the why we use the American, senang je, because the Shigley is coming from America, kan? Alright. So there is a the easiest answer sebenarnya. Alright. So if you look at the last point here, it said that table -1 through 13-5 Shigley's has explained all the necessary term of 4 gears. Okay. Dalam slide ni ada 13. Alright. Ada orang tanya ke? Sekejap. Okay, tak ada orang tanya. Saya kan ada orang panggil saya. Alright. Okay. Just a moment. Alright. Okay, let's talk about the spur gear. What is a spur gear? I think this is a gear that normally that we use. Okay. Alright, if you look at this, why we call gear? Because the teeth, okay, is parallel to the axis of rotation. So what is the teeth? Inilah dia teeth ni kan. So it is what call it sama arah dengan shaft. Okay. So sebelum saya pergi lebih jauh, okay, saya nak cerita pasal gear ni. Macam mana gear ni datang Okay, gear ni datang sebenarnya okay, based on the cylindrical cylinder Okay. Dia datang daripada cylinder. Just a moment. Saya tak boleh nak lukis Okay. Alright. Dia sebenarnya asal ni lah. Okay. Alright. So what is the problem? Okay, this is very orang kata curve. Okay. So if you turn into this direction, the other gear will be turn into the opposite direction. Okay. So ini dia punya asas. Kita anggap dia sebagai cylindrical cylinder, tapi the problem is disebabkan oleh friction. Okay, engineer has to put the teeth. Itu sebabnya. So that's why in our calculation basically we are refer to the circle. Alright. So awak boleh quote lah. Okay. Yes. Kejap saya pandang balik. Alright. Okay, as usual, it used to transmit motion. Okay, betul lah kan, transmit motion lah. That is a very common sense lah. Either in the torque ataupun dalam bentuk. Sorry? Apa dia? Saya tak dengar. Anybody? Tak. Ada orang bercakap, saya tak tahu apa ceritanya. Okay, tak apa. Kalau ada apa-apa boleh lah. Alright, please mute your mic if you don't want to talk, please mute sebab takut ada orang kata noise Alright. So the characteristic of spur gear is pertama adalah the teeth must parallel to the axis of rotation. Okay. Alright. Okay. And that also the teeth is the orang kata work on parallel shaft macam saya sebutkan tadi. Alright. Okay, the common uses watches and blah blah blah. Alright. So the spur gear is the simplest. Okay, saya cakap tadi sebab dia cylindrical roller dan all the calculation we base on this type of gears. Alright. Okay, just a moment, mana pen saya. Okay. Alright. So this is the the spur gear. Okay, yang ni awak tengok ni the rack and pinion. Okay, which is normally used on your uh, uh, power steering lah, power kereta, and then for auto gate yang jenis yang sliding tu. Alright, yang jenis yang sliding tu biasa kita gunakan kat situ lah. Alright, so this is the gear. Alright, the teeth, you have the shaft at the center. So that is a spur gear. So our calculation we based on this type of gears Alright. So let's move on the helical gears. Okay, helical gears ni the differences with the spur gear cuma dia punya orientation, teeth dia incline. Okay, the teeth incline toward certain of degree, usually on 10 to 45 degrees. Alright. So this gear usually is not noise Kenapa tak noise? Dia dah terbut kat sini because the more gradual engagement of the teeth during meshing. Meshing ni maksud dia adalah when they are start to contact each other lah. Itu maksud meshing Alright, ataupun dalam bahasa lain kita panggil dia mating ataupun meshing atau mating. Ada dua terms yang kita boleh guna dekat sini. Alright. So kenapa dia kurang noise? Sebab kalau awak tengok dekat ni, kalau dia start kena maksudnya macam mana cakap kalau dia start engage, if you look at this semua the whole point kat sini kan, the thickness of the teeth of gear akan contact. Alright. Untuk helical gears usually only one point. That's why dia tak noise. Alright. So the inclined tooth also develop thrust load. Okay, if you look at this statement and also bending couples. Alright. So saya nak tanya, thrust load ni bagus ke tak bagus? Nak tanya, what is a thrust load? Okay, thrust load ni maksudnya kalau awak gunakan this kind of helical gears, okay, the gear will move along the shaft. Dia akan move. Okay, kita bagi the torque at this direction. Okay, bila yang kena ni biasanya dia akan gerak ke kiri atau ke kanan depend on the orientation of the teeth lah. Okay, ataupun inclination of the teeth lah basically. That's why we have a thrust load. Okay. Alright, so kalau ikutkan the general statement here, he said that okay, it can transmit between parallel and sometimes I used to transmit motion between non-parallel shaft. Okay, tapi biasanya kita gunakan for parallel shaft. Okay, this is example for the non-parallel shaft Okay. Okay, saya padam balik. Alright, semak Alright. Okay, what else? Okay, this is non-intersecting shaft. Okay. Alright, so used to reduce noise and vibration. Okay, macam saya tadi lah sebab the contact point dia is very small as compared to the spur gear. So usually kalau awak tengok this kind of gear terpakai kepada high rotation speed for example your gearbox car gearbox, motorbike gearbox, this is the common application. Alright. So this is another kata type of teeth we call it herringbone gear. We have a double cross helical gears. Okay. Alright. Okay, clear So hopefully that this is straightforward. Tak ada masalah sangat. Okay, let's move to the next slide, which is we're going to talk about the beaver gear. Okay, so what is a beaver gear? Okay, beaver gear usually the teeth, okay, they are already cut. Kan? Instead of straightforward, okay, dia dah cut kat sini supaya we can have two perpendicular shaft. Okay, kenapa kita panggil dia perpendicular shaft? Usually, let's say this is a shaft. Okay, usually dia akan not contact lah, I mean that dia punya tu dia the axis lah of shaft will intersect each other. That's why we call it as the intersecting shaft. Kan? Alright. Okay, so the teeth, okay, kita panggil dia mating cones Kita panggil dia mating cones. So awak jumpa lagi perkataan mating ataupun Satu lagi apa? Saya lupa dah. Meshing Okay, mating atau meshing Alright. Okay. There's a three types of the beaver gear. Okay, you can see this is very straightforward. You can also have the yang berbentuk yang curve curve punya teeth. Alright, we call it as the spiral beaver gear. Okay, we have a straight two lever gear, which is a normal one, and we have the spiral gears. And the last one we have a half weight gears. Alright. So spiral gear run more smoothly and quietly. Macam saya kata lah, because of the contact point tu lagi kecil berbanding dengan the normal one. Alright. Okay. So yep. Okay. This is talk about beaver gear, and let's go about the worm gears. Okay, worm gears. Okay. So why we call it as a worm gears? Okay. Alright, worm gear ni simple. It has a very continuous teeth macam ni kan. Continuous teeth. Okay, macam bentuk screw tu, and then we interact with the another set of gears, which is a normal one lah. That's why we call it as a worm gears. Alright. These gears usually is self-interlocking. Okay, sebab apa? Sebab once you have rotate these worms, okay, usually there is no, dia akan, this is one way lah. This is one way punya ni. Kalau katalah, for example that this is the spur gear kan. If you move this way, okay, alright, so this you react, isn't it? So katakanlah awak move in this way, okay, this also will interact the other way around. So for worm gears, usually if you move this gear, doesn't matter it's counterclockwise or clockwise, okay, katakanlah awak if you move in the second gear here, okay, dia tak akan bergerak lagi. So that's why we call it as the self-locking. So kat mana awak pakai biasanya worm gears ni? Usually kalau awak, if you are you are a musician, for example you are playing guitars, violins, all that. So misal bila awak nak tuning kan, if you want to tune, kan awak press, dan tali tu makin lama makin tension kan, right? So dia tak akan kembali kepada asal balik kan. Alright, so this is that's why we call it as usually self-locking. Alright. So the direction of the worm gear depend on the direction of the rotation of the worm, and also the teeth, sama ada the teeth in right hand ataupun left hand. Okay, so tengoklah dia punya direction ni based on the teeth ni Kalau teeth sini mungkin direction dia ada side, kalau teeth di belah sini on the left side mungkin dia akan bergerak ke arah lain. So that is the characteristic of the worm gears. Okay, tak ada masalah Alright, so kalau awak tengok this statement, dia kata a worm gear and a worm together are called worm set. Okay, worm gear and a worm together are called worm set. This is worm gear. This is the worm. We call it as a worm set. Alright, so I think this is straightforward. Tak ada issue sangat. Okay, let's go to the next slide. Alright, okay, this is very important. Awak kena kenal gear Alright, even though you are not design the gears, but you must know the terminology used, okay, about the gears. Okay, alright, because you will do some calculation. Okay, so this is a nomenclature, alright, about the gears ataupun terminology lah dalam bahasa mudahnya. Alright, so there is a lot of word here that you need to remember. Okay, dan saya rasa the most important part yang awak kena ingat, tak apa, is on the 2D side. Okay, on the 2D side, maksudnya kalau macam macam top land and then macam face and flank ni awak tak ingat tak apa, tapi kalau this on the 2D macam you look from here, okay, this is the most important lah kan. Alright, so let's talk about this terminology. So the highest diameter of the gear, we call it as a top land the top land, the highest diameter lah of the gear. Okay, the top land lah. Alright, when we have the bottom land here, okay, we have the face, we have the flank. Okay, alright, let's have a look on this the first what call it, pitch circle. Alright, so if you look at this statement, it says that a theoretical circle upon which all calculations are usually based. Okay, so this is the pitch circle. Okay, saya lukis. Okay, so kenapa kita panggil dia pitch circle? Pitch circle ni macam saya, like I said earlier, so the gear is coming from the cylindrical. Okay, cylindrical ni kan, cylindrical punya roller kan. So basically pitch circle ni actually can be defined as the diameter ataupun the diameter of the roller sebenarnya. Okay, that's why we said all the calculation are usually based. Alright, okay, saya padam sekejap. Okay, this is pitch circle. Okay, and we have the pitch diameter. Alright, so we have the pitch diameter. So this is the pitch diameter is a diameter of the pitch circle, maksudnya sinilah sampai ke hujung satu lagi. Okay, this is the pitch diameter. Alright, and we have the module. Okay, the ratio of the pitch diameter to the number of teeth. Alright, this is constant basically. Okay, usually module ni is very constant. So dia nak tahu for each, okay, how many number of teeth for each diameter. This is very constant That's why we call it as a ratio. Alright. So yang awak nak kena tahu ialah pitch diameter ni is very common dalam calculation nanti. So you have to take care about this. Alright. Okay, next. Circular pitch. What is a circular pitch? Circular pitch actually the distance from here. Okay, this is your pitch circle. Alright, distance from here to here lah basically. From the tooth to another tooth. Okay. Alright, so tooth, another tooth So the pitch circle can be, kalau awak ambil kat sini pun sama juga kan, dia punya pitch circle tersebut. Alright. Okay. Alright. Next, about addendum. Okay, addendum is the area from the pitch circle to the top length. Okay, we call it as addendum. This is addendum circle. Okay. Okay, penting addendum circle ni penting because addendum circle ni where the contact take place. The first contact of the gear happen at the addendum circle sebenarnya. Alright. Okay. So, okay, this is addendum circle. That's why a radial distance between the top length and the pitch circle. Okay. Alright, we have an addendum which is coming from the pitch circle ke bawah, selepas addendum ke bawah sampai kepada bottom length. So we have the dedendum. Alright, half of the teeth lah basically. The first half we call it addendum, the second half we call it as a dedendum. Alright, so we also have the whole depth, okay, which is addendum plus dedendum. So the ataupun kita panggil dia sebagai tinggi lah kan, tinggi of the teeth gear tu lah. Alright, call it as a whole depth. Okay, next. And we have the clearance circle. Okay, this is the clearance circle. Okay, alright, because kenapa circle, kita ada fillet of the radius. Okay, usually kita punya mating ataupun meshing of the gear akan stop kat sini je lah. Dia tak akan pergi bawah lagi. Kalau pergi bawah dia akan berlaga dengan bottom length. So usually the action of the tooth actually between the addendum up to here. Alright. Itu maksud dia lah. Okay, that's why we call this area and that area lah. Okay. Okay, boleh follow So it's very straightforward. Hopefully you can understand. Alright. And let's move on into the next slide. Okay. Alright. Sekejap. Okay, this is the clearance kat sini. Okay, ni tak ada apa sangat lah kot. Alright, so yes, this is a very important formula dan selalu akan ditanya dalam during your exam. Alright, so okay, so the distance, let's say that this is the gear. Okay, before that, sebelum saya nak cerita lebih lanjut, okay, biasanya gears ni, okay, kalau you have a two set of gears, okay, the first gear ni, okay, we call it as the pinion P-I. Ya, saya cuba lukis sekejap. Okay, this gear we call it as the pinion. What is the characteristic of pinion? Usually gear ni adalah lebih kecil berbanding dengan second gear. So this gear ataupun second gear ni we call as the gear. Alright. So kadang-kadang soalan tanya, there's a pinion 15 teeth dan mating with the gear 30 teeth. So pinion means refer to the smallest gear. Alright. So about this slide basically, okay, this is the center distance, okay, antara jarak di antara gear first and the gear pinion and the gear lah. Alright, so we call that center of descent. And another important thing is about the pressure angle. Pressure angle yang awak nak kena tahu. So, what is a pressure angle? Pressure angle ni sebenarnya adalah teeth lah. Dia punya orientation teeth tu. That's why we call that as pressure angle. Alright. So, pressure angle is very important when you like to calculate the, okay, kemudian. Tak apa, itu cerita kemudian. So, just to let you know lah what is the important of the pressure angle. And also the pitch diameter, macam saya cakap tadi lah. Okay, the pitch diameter yang penting tu kan. Yang saya kata, there is a contact of the teeth between the two gears Alright. Kalau awak tengok sini, dia betul-betul macam, dia punya definition betul-betul macam roller cylindrical Dia akan mat ataupun akan touch kat sini dia punya silinder, dia punya diameter tu. Alright. So, okay, this is a formula how to determine the tooth size. Okay, buat tengok. Okay, N besar ni, so benda yang awak biasa akan jumpa adalah N N besar. Awak biasa akan jumpa N kecil dengan M. Satu lagi adalah P, which is the diameter pitch. Biasa awak jumpa lah. Alright. So this is a formula that usually been used. Right. Okay. Alright. So kalau if you look at this table, this is another formula juga yang biasanya untuk determine the size of the teeth, the size of the, orang kata, the module. You want to know the number of teeth, center of distance. Okay. Alright. So this is formula is quite famous, been asked in your test. Alright. Okay. Ada soalan tak? Do you have any question regarding on this slide? Tak ada Kalau tak ada tak apa. We go to the move to next slide. Alright. So basically untuk gear ni kita akan buat exercise lah kot next week about the gears Alright. So kita akan buat exercise sama-sama so that you can familiar with the questions later on. Alright. So biasanya soalan gear ni tak very straightforward lah kebiasaannya lah. Yalah, walaupun the question is open textbook, kalau awak tak buat orang kata you tak buat exercise, you will not be able to answer it. Okay. Alright. So kalau tak ada apa, let's move on into the next slide. Okay, ni yang table tadi tu yang awak tengok, saya kata 13-1 to the 13 tu kan, about the characteristic of gear lah. Okay, so awak tengok sini kita ada jenis tooth system. Okay, usually we are using the full depth. Okay, basic kita pakai pressure angle about 20 degrees. Alright, so by having this kind of information, kita tahu dia punya addendum dengan dedendum punya size. So M is a module, macam tadi, we have the pitch diameter kan. Right. So by doing the calculation, you will know. So this is very important for those who are going to, nak draw gear, betul tak? Kan? So this is very important. Awak nak check balik betul tak awak lukis. Alright. So we also have the module. Modules basically is a constant Biasanya this is standard. Kita ada 1.25, 1.5, 2.0. Okay, tak ada 1.115 tak ada Jangan awak kata pergi kedai, awak kata minta 1.15 module, tak ada. This is a standard. Alright. Okay, ni also ada lagi table bertentangan dengan lead angle. Okay, we have the pressure angle as well, dan also the addendum. Ini dia tengoklah type of gear. So depend of it. Alright. Okay, bawah ni ada exercise. Okay, boleh tak buat exercise ni? Right. It's very straightforward. Okay, awak tengok sini soalan dia. 18 tooth pinion, okay, is mesh with 32th gear. Tengok nama dia, 18 is a small gear ataupun the small number of teeth. And yang kedua adalah gear. Given that module, okay, of the gear is set 12 mm per teeth, maksudnya every 12 mm je distance, awak ada satu teeth. Determine pitch diameter for the pinion and gear. Boleh jawab tak? Rasa-rasanya. Apa formula nak pakai? Alright. Okay, I think this is soalan ni very straightforward. So M module is a constant basically. So what you need, the formula that you need to use is this one Saya putih balik. Yang ni lah. Kan? Sorry. So the formula that you need to use is this one. Okay, awak dapat module. Awak tahu dia punya what call it, pitch diameter, then you will know the you know that the question asks you to find what is a D, but you are given number of teeth. Okay, so basically you can answer it. Boleh jawab tak? Saya bagi awak 2 minit. Tengok, baca soalan jap, tengok rumus tu. Okay, so okay, hopefully you can bear with me. Alright. So kalau tak ada isu, okay, I give you 2 minutes to have a look so that you can familiar with the terminology Okay. So saya padam sekejap. Okay, 2 minutes. Dia punya jawapan tak dalam slide ni saya rasa this is straightforward, tak perlu lah kot. Ini jawapan, just insert into the formulas saja. Tak mau padam. Kenapa tak mau padam? Sekejap. Okay, tak apa. Okay kalau awak dah tengok, that's fine. Awak cuba tengok, especially the terminology macam pitch diameter semua tu addendum, dedendum. So hopefully you can familiarize with the terms because kita akan gunakan lagi after this, alright? Okay, sebentar tu minum kopi jap. Okay, ada soalan? Tak ada Up to here? Kalau tak ada masalah. Okay, let's move on. Okay, alright. Kita go to the next slide, which is the gear tooth shape. Alright, if you look, okay, gear tooth shape. Kenapa kita kena belajar ni? Alright, sekejap Saya tak boleh nak tulis kenapa Okay, boleh. Okay, kalau awak perasan kita punya gear ni is not a straight line Okay, if I reverse back into the terminal gear punya ni, kan, if you look at this, the gear is not really a straight. So there's a curve into it. Okay, there's a reason behind it. Okay, kenapa kita perlukan bentuk curve instead of straight one. Okay, that's why this slide came to. Alright. So according to, if you look at the first statement, he says here, gear tooth contours must be conjugate of each other. Apa maksud conjugate? Okay, conjugate means that, okay, the teeth, conjugate means that if the mating ataupun if the meshing gears produce a constant angular velocity ratio. Okay, so that's why we have the conjugate action. Alright, maksudnya conjugate action ni kita nak pastikan dia berada dalam constant angular velocity ataupun omega lah. Kan? Betul tak? So maksudnya katalah you have a two type of gears, for example this gear and this gear. Okay. So katakanlah dia gerak dia gerak katakanlah 30 km per second for example ataupun gerak 200 RPM for example. So this gear kena make sure that dia gerak, katalah dia design to gerak 300 RPM. Okay. So kita nak pastikan dia punya angular velocity dia adalah sama. Kita tak nak at certain place tiba-tiba dia bergerak laju sikit daripada ni. Okay, that's why the teeth is designed, there's a contour on it. Alright. Itu maksud dia lah dekat sini. Okay. That's why it must produce the angular velocity. Right, that's why we can call it as a conjugate action. That's why awak punya teeth itu is not really straight, there's a curve, and this profile we call it as the involute. Okay, profile itu adalah involute we call it. Macam ni, katalah this is the teeth gear. Ini kita panggil dia involute punya profile lah, teeth. Okay, alright. So maksud je, what is the advantage to ensure that center distance error do not affect velocity ratio. Kadang-kadang kat sini kan dia ada clearance kan. Kalau ada awak masuk masuk shaft ataupun masuk bearing, so that it can produce a very constant velocity ratio. Alright. So ayat yang bawah ni sebenarnya adalah although that you are required to design the teeth, but at least you know how they create it. Okay, so the last sentence here, it says that how to draw a teeth, gear teeth. So macam mana dia draw? Okay, dia tarik center head kepada circle. This is we call it as the base circle. Okay, alright. Base circle ni tak ada dalam terminologi tadi. This is a base circle. Nanti kita terangkan what is the important of base circle ni. Alright, dia akan buat satu tangent. Sebab why is tangent? Because the power is transmit through the tangent. So bila awak buat ni nanti sebenarnya at the end of the day awak akan dapat this is two profile lah. Two profile. So bila awak buat nanti awak akan dapat satu lagi profile kat sini. Okay, itulah sebenarnya this how to create ataupun how to draw the teeth. Okay, itu maksud dia lah. Alright. So tak perlu belajar tapi awak tahulah apa maksud dia. Kena ada tangent So sebenarnya bila the load is transferred, we need a tangent between the teeth. That's why kita kata tangent sebab nanti kalau ada gear kat atas ni kan, nanti dia akan contact dengan the next teeth using the tangent. Alright. Okay, the conjugate action. Alright. So what is the importance of conjugate action? Okay. Alright. So kalau tengok sini, this is not gear This is actually the cam and the loop. Dia cuma nak cerita kat sini macam mana conjugate action can orang kata create a new formula kat sini sebenarnya. This is a formula. Kan? Alright. So maksudnya yang paling penting adalah kat sini adalah at the end of the day, bila the contact of the cam atau loop dia akan hasilkan satu garis lurus. So we call it as a line of action whereby the tooth contact each other. Alright. So by having this conjugate action, we can have this formula which is the omega 1 divide by omega 2 inversely proportional to R2 per R1. Okay. Alright. So I think the common sense awak tengok kat sini kan, kalau you ride a bicycle, right? So you ride a bicycle. Okay. So awak ada, saya cuba lukis. Kenapa formula ni ada? Saya rasa awak boleh bayangkan, okay? Sebab awak naik basikal kecil-kecil dulu. Tak tahulah awak dah kecil naik motor terus kan, saya tak tahu Tapi the common sense something like this. Katakanlah ini basikal awak. Sorry, saya tak ingat. Okay, this is orang kata pedal awak kan, betul tak? Pedal basikal awak Okay. So biasanya if you want to go to the kalau awak nak go to higher RPM, usually awak akan ambil gear belakang awak mesti kecil. Okay. Tapi bila awak means that tapi when you are try to climb a hill ataupun bukit, usually you use the gear lagi besar. Okay, awak nampak tak kat sini apa maksud dia? Okay. Alamak. Alright, you can see that kalau awak nak speed, usually awak nak racing ataupun awak nak dah you don't need acceleration, you just use the small gear. Katalah ni rantai kan, betul tak? Tapi kalau awak nak naik bukit, awak perlukan gear lagi besar. So, apa maksud dia? So, let's say kalau awak nak high speed, okay, katakanlah awak nak high speed, katalah gear awak, biasalah awak nak W2 kan, awak nak tinggikan W2, obviously awak perlukan gear yang lagi rendah. This is radius lah, ataupun dia punya distance lah, ataupun diameter. So, common sense kat sini, kalau awak nak speed tinggi, apa yang awak perlukan adalah awak perlukan the small gear. W2 ni refer to second gear lah. Okay, this is number 1 lah. Betul tak? So, it's common sense kat situ Kata kalau awak nak speed rendah, awak turun. So, punya radius kat belakang tu jadi tinggi. Okay? Itu maksud dia kat sini. So, biasanya kalau this is that we, kalau awak, if you look at this, nak beli kereta kan, atau motor kan, dia kan ada tulis gearbox punya karakteristik kan. So, dia akan bagi tahu what is your final drive, what is the ratio. Inilah dia. Kita refer pada ni. Kita panggil dia sebagai gear ratio lah kot. This term ni awak akan jumpa lagi lepas ni lah. Kan awak beli motor kan, awak tengok berapa gearbox, berapa final drive, berapa bawah ni. So, kan, this is a spec that was given by the manufacturer about the gear ratio ni. Alright, so hopefully you can understand about this conjugation what is important thing important about the conjugation. Alright, so alright, so this is about dia nak cerita pasal about the profile of the teeth lah tak ada apa sangat lah yang ni. Alright, okay, we have the base circle. Okay, alright, so happening is, okay, apa biasanya untuk pitch circle ni biasanya akan contact dekat sini untuk dua gear, and then we have the ni lah base circle ni lah kat mana dia start contact teeth tu. Alright, so tak apa, I think this is not really important for you lah. Okay, this slide tak ada apa pun, dia just to tell you what is the teeth tu, kat mana dia contact. Alright, so this is teeth lah, this is teeth from here, gear 2, this is teeth coming from the gear 1. Alright, next. Alright, so so this is the one we go into deep punya orang kata discussion about the circle of a gear layout. Alright, so what happen is, macam saya cakap tadi lah, macam cam and lobe tadi tu, if you put it into the gear, alright, ni lah paling penting ni, kita panggil dia action offline tadi kan. So dia punya orang kata degree kat sini kita panggil dia pressure angle. Okay, alright, we call it as the pressure angle. Alright, so boleh faham so tak ada apa, this is the teeth punya gear. Alright, dia ni nak cerita position of the base circle and also the pitch diameter lah, ataupun pitch circle kat situ. Alright, nak cerita lah macam mana the design of the gear. Alright, I will go to the next slide. Okay, alright, this is we call it as the pressure ataupun line action Alright, kat mana dia berlaku. This is a pressure angle as well. Okay, alright, all this information dia nak cerita macam mana the sizing of it. Okay, alright, based on the pitch circle, base circle, alright, and everything. Okay, ni tak penting sangat. Alright, okay, ni penting, saya nak kena cerita. Alright, so what happen is, this talk about the tooth action. Apa yang berlaku adalah when this teeth, okay, let's say that this is a teeth, start to contact the other teeth from this gear. Okay, kan dia start contact. Teeth yang kedua, based on the pinion ataupun driver, okay, position dia adalah at the last point. So, bila katakanlah this gear gerak sikit, this gear akan keluar daripada meshing tadi lah. Okay, itu maksud je lah. Alright. Okay, macam ni kata, this is a line of action tadi, this is a pressure angle, theta tadi tu. Alright, so what happen is, kalau tengok dekat sini, kat mana dia start meshing? Okay, if you look at this tooth, dia start dekat this line lah, which is the addendum circle of the gear. So, dia start kat sini, nampak tak? Kan, dia start kat situ, dia touch kat situ. Yang gear yang second tu, dia dekat mana? Dia dekat di dendam circle lah, dia terakhir kat sini. Itu maksud dia, macam mana dia punya gear. Alright. Okay, that's why awak tengok dia last. Okay, the first point of contact at A where flank of the pinion touch tip of the gear. Okay, pinion tu yang the top part kan, the first top part of the gear, and the last point of the contact AB where tip of pinion. Ni the last contact lah. So ini kat sini kita panggil dia akan berlaku di contact ratio lah. Kat mana dia punya transfer tu. So the most important thing saya nak cerita tentang angle of approach and as well the angle of recess. Okay, apa kepentingan dia? Nanti kita tengok. Alright. Sekejap Okay, sekejap. Apa lagi nak cerita kat sini? Alright, itu je lah saya rasa. Nanti kita cerita balik. Angle of approach, angle of recess. Theta lah kan? Betul tak? So itu macam mana dia punya contact of the gear tu berlaku So dia punya contact ni paling penting kalau katakanlah ada clearance dekat sini. Contohlah awak dah start contact sini tapi awak ada clearance dekat sini. Kat situlah hasilnya bunyi ataupun bising lah. Sebab awak akan berlagakan bunyi tu nanti. Kan? Bila awak dah contact kat sini, tapi kat sini masih ada clearance kat sini. So maksudnya gear, the design of gear is tak sesuai lah kat situ. Kita nak pastikan bahawa when is the first contact here and the second gear, the second teeth kat sini start to leaving the action. Alright, start to leaving the surface. Alright, so kalau berlaku ada clearance, basically there is a noise coming from. Okay, itu dia punya kepentingan dia lah. Alright, so saya akan padam sekejap Okay, agak mess Alright, ada soalan tak? Saya nak tanya kat sini. Do you have any questions? Tak ada.
Sir.
Ya.
Kan apa tu tadi kalau ada clearance dia buatkan bunyi kan?
Betul.
Clearance by maksud sir apa maksud clearance yang dekat mana?
Okay, clearance tu Okay, macam ni. Okay. Sekejap Alright. Okay, kita nak yang saya cerita tadi tu cuma nak kita tahulah macam mana kenapa pentingnya design orang kata the teeth tu kan. Penting kepentingan dia sebab apa tahu? Sebab katakanlah this is you start contact. Okay, sekejap kenapa saya tak boleh nak. Okay, katalah this is start to contact tapi kat sini dia ada clearance kan. Maksudnya dia tak kena. Dia tak kena. So apa berlaku sebenarnya adalah dia macam awak akan give a hit ataupun hentaman kepada gear tu instead of the kita nak gradual transitioning edge of the contact tapi bila aku tu maksudnya dia akan berlaku hentaman kat situ. Alright? Kan? Itulah maksud dia lebih kurang. Faham tak? That's why kita ada standard sebenarnya berapa jarak. Contoh teeth ke teeth ni ada dia punya jarak dia nanti. Kenapa kita tak suka jarak dekat, jarak jauh tak? Dia ada standard. So apa yang dia cuba cakap to action ni adalah kita nak bagi tahulah macam mana gear tu efficiency of gear tu macam mana. Okay. Macam saya cakap tadi kan the first one. Kenapa why the yang gear yang inclination teeth tu lagi better, lagi senyap berbanding dengan spur gear sebab the contact dia very small kat situ.
Very small.
Macam tu juga. So it's just to tell you about that. Okay. So tak apa. This is extra knowledge je lah. Tak ada apa pun. Okay. Tak ada apa sangat lah. Supaya awak faham lah kenapa the design itself must be accordingly sekian. Alright. So this is the theoretical lah. The engineer develop gear teeth lah. Itu je lah. Alright. Okay. Last end of the day. Last soalan. Okay. Tak apa. Saya tak nak buat soalan ni because I think the first thing because this example is in the imperial kan. Saya tak suka imperial basically. Tapi tak apa. Basically the same pun kan. Soalan dia pusing-pusing macam tu juga. Sebab based on the formula yang sebelum ni. Okay, tak apa. Saya akan hold this question. Kemudian, alright. Kemudian okay, itu kata contact ratio tu. Yang last kali tu adalah arc of action, arc of recess. Ini kan bila dia start yang tadi tu kita panggil dia contact ratio. Apa maksud saya tadi itu adalah contact ratio tu adalah dekat sini lah. Kita petang balik. This is contact ratio tadi lah. Contact ratio. This is the contact ratio. Okay. Kita kira. That's why awak tengok kat sini. The next slide is QR campur dengan QA. Kan? Arc of action plus arc of mission become the arc of approach. Okay, dan awak bahagikan kepada diameter pitch, we get the MC. So what is important the MC is, if you look at this statement, the last one you get, alright, if contact ratio figure should not less than 1.20. Why? Because inaccuracy in mounting might reduce the contact ratio, therefore increase impactive and generate noise. Itu maksudnya. So when you this is very important lah for those one who are try to lukis gear kan. This is you should have a look lah. Alright, so kalau M is less than 1.20, it will generate noise because of the clearance. Okay, alright, this is the contact line tadi kot. Yes, this is the contact line. This is the pressure angle. Alright, so this is the arc arc tadi tu. Campur dengan arc ni, you get the arc of approach. You divide by diameter pitch, you get the this one, the contact ratio. Alright. So boleh ikut saya Hopefully that is important Okay. Itu berlaku kat sini lah. Alright. Okay, kalau tak ada apa salah. Okay, interference. Okay. So what is interference? Interference ni adalah kalau dia punya profile is not conjugate ataupun dia punya action of the motion is not conjugate, okay, kita call it as the interference lah. Maksudnya ada gangguan lah. Okay, that's why kita are not conjugate, we call interference. Apa yang berlaku adalah the contact happen below the baseline. The first contact macam ni, this is the baseline kan. This is the baseline. Sorry, which one? Okay, sorry. And this is the baseline. Okay, the contact is happen below here. Apa berlaku, dia macam you hentam you hentam the teeth. Okay, so interference is not desirable. Okay, so macam mana nak solve the problem is kita gunakan large pressure angle. Biasa kita pakai 20 degree kan. Okay, maybe you can try to 22 degree. Okay, itu maksudlah lebih kurang. Alright, so okay, so what is the advantage of using the larger pressure angle is increase in radial force. Okay, what is the radial force? Radial force ni adalah benda, so kalau awak tengok sini, apabila dia start contact ni, dia contact, kita ada tangent kita ada, radian is any force that towards the center. Kita tak nak tu. Rugilah. Maksudnya, it's not efficient anymore. Kita punya transfer of the load is between the teeth, basically based on the tangent force. So, kalau ada berlakunya radial force, maksudnya awak akan letak pressure to the shaft. Kan? Contohlah awak ada shaft, awak ada radial, this is the radial force. Okay. Yang awak letak forward to the radial, terletak pada shaft. So maksudnya shaft will sustain more loads. So tak efficiently lah kan. Kalau that's why kata interference is undesirable in this case. Alright. Okay, itu maksud dia lah kat sini Alright. So maksudnya if the radial force is very high, probably that more load is sustained by the shaft. Probably kalau size of the shaft boleh buat 10 cm panjang, cm diameter, you have to increase the size because of the load, of the radial load. Okay. Alright, tak apa. Kita akan move on into that particular area nanti kemudian maybe next week lah kot. Saya akan tengok keadaan sekarang lah. I think next week lah. Alright, saya akan touch balik benda ni. Okay, alright. So boleh faham So interference is undesirable Alright. Okay, nak lihat tak? Dah sejak. Yes.
Saya nak tanya. Kan apa tu, interference boleh hilangkan by large pressure angle kan?
Okay.
Lepas tu macam mana kita nak, kalau kita punya design ada small pressure angle, macam mana kita nak increase that pressure angle?
Okay. Dia senang je. Alright, so macam lah case awak kan. Awak cakap you are asking about your project group ke macam mana?
Somewhat relative.
Alright, so senang je. Bagi saya senang lah. Tak pening-pening. Awak design tu based pada yang sebelum ni lah. I mean, kalau kata lah awak, okay, macam interference ni sometimes maybe the distance ataupun gear tu macam dia punya, contohlah dia punya housing of gearbox very small, awak nak compact kan, awak terpaksa rapatkan gear teeth tu kan. So mungkin berlaku interference. Tapi dalam case macam awak, tak perlukan. Kenapa nak buat interference, betul tak? So follow je yang slide sebelum ni. Apa dia punya requirement dia. Contoh kat sini dia kata Kan ada table tu kan, berapa besar addendum, dedendum semua kan, betul tak? So follow je
Betul.
that kind of design code kita panggil dia. Kan? So that you
Okay.
can reduce the interference. So interference ni is just advanced knowledge lah kot saya rasa. Alright, so kenapa kalau tak boleh gigi tu apa, kenapa, yelah basic kenapa gigi tu 20 degree bukan 22 degree, ni sebab dia lah, sebab ada interference.
Okay. Thank you,
Interference
sir.
ni should be avoid lah basically Alright.
Alright.
Okay, sebab yelah saya tak tahu in future you are going to work with somebody kan, probably that after this you are working with the apa, macam yang buat gear kan, macam awak kerja dengan proton ke, awak terlibat dengan kilang Jepun for example, macam proton apa, gearbox dia punya manufacture saya from the Belgium Punch company. Kalau macam Toyota dia ada Aisin tak saya, Aisin satu lagi saya tak ingat dah. So probably that you are working with that. Then if I'm not mistaken Prodo already started before this, you know Myvi kan, the king of the road though. Right, the gearbox is actually I think the first generation or second generation there's a gearbox is coming from the Japan. Alright. Okay, so I think the last few years, 4 or 5 years ago, they already assemble it. Okay, probably that you are working in that area lah kan nanti. So this is a basic knowledge lah, awak boleh cerita lah tentang about the gears. Alright. Okay. Alright. Okay, can we rest about 2 or 3 minutes? Is it possible? Or you want to continue? Okay, macam mana? Boleh? Nak rehat ke nak teruskan?
Nak rest.
Nak rest. Okay, ini belum teknikal lagi Ini belum teknikal lagi. Okay. Alright, Adi kalau masuk lepas ni ada teknikal sikit. Alright, so kalau boleh buatlah kopi ke apa kan, cekedis ke whatever it is, okay. Chewing gum ke on your side Alright, kopok lekor ke whatever it is lah. Okay. Okay, I will meet you again around 2 or 3 minutes Alright. Okay, I will see you soon. Kalau ada soalan boleh type kot. Kalau if you prefer to type, you can type. Okay, if you like to talk to me, then you are welcome to do so as well. Okay. Okay, so we wait another 1 minute and we can start. Okay, let's move on. Alright. Okay, macam when talk about interference tu, so the other way is to reduce is by using motif in the pinion kalau kat sini Satu lagi adalah terms yang kita gunakan sini adalah undercutting. Alamak, tak keluar lah pula. Okay, undercutting Alright, kenapa kata undercutting? Maksudnya kita kena buat cutting ni besar lah. Kan, we had it. So undercutting maksudnya dia belaga kat sini kan. So something that we don't want it lah. Alright, so that's why kita perlukan dia punya angle of the teeth lagi tirus lah, lagi tajam lah. Alright, so that is a mean by the interference. Okay, sebab apa? Kenapa saya highlight this thing? Because nanti ada soalan akan bertanya tentang tu. Okay, the question we ask it about the why we have to use 16 teeth of gear alright. Okay, tak apa. Alright, let's go. Okay, this slide is quite straightforward. Alright, so this is the slide tells you how to form a gear. Okay, you can do it by using direct way. Okay, this is for metallic metal sand casting. You can use the shell molding. Okay, you use the powder metallurgy. Okay, you can use the permanent mold casting. You have your centrifugal casting and so on. Okay, so the second text is tell you that the gear can be done indirectly using the milling, shaping and hobbing. Okay, usually this thing is take times lah. Alright, and perhaps that you need to have the finishing such as grinding and lapping. Okay, so for the gears that make plastic, it can be as alright, polycarbonate, acetal. Okay, usually they are used by the injection molding. So mainan banyak menggunakan ni lah, plastik lah. Alright, either is a thermoplastic or thermoset lah basically. Alright, so this is about the milling. Okay, macam mana milling? Milling ni ialah dia akan cut lah. Kan, dia akan cut along the way lah, dia punya teeth tu lah. Okay, alright, saya rasa saya tak perlu nak detail sangat benda ni. Okay, alright, so this is a hobbing. Hobbing means that digunakan this is a hob lah, we call it as a hob. This is a blank. Okay, hob pasal dia macam worm kan. So worm, so bila dia lalu je dia akan cut the teeth. Alright, itu maksud dia lah hobbing. Okay, the next one is a shaping. Okay, alright, shaping means that we have a die. Okay, this is a die. So awak akan masukkan sampel ataupun the blank into it, then you rotate it and the shape of the teeth will be constructed. Alright, okay, this is very straightforward lah. Alright, soalan tak akan tanya ni lah basically. Okay, alright, kalau tanya is bonus lah. Alright, so this is very straightforward okay. So ada dua kalau yang extra awak belajar adalah hobbing dengan shaping. So if you want to know how it make cut, I think you can refer to the YouTube There's a lot of video about it. Okay, I don't want to touch this too much. Okay, this is very technical yang saya nak kena cerita. Okay, awak kena stay with me or bear with me lah. Alright. Okay. So this is a gear tooth theory. Okay, gear tooth theory. Kenapa saya tak boleh? Okay, alright. Macam saya tadi, pinion is a smaller gear. Okay, gear is the highest gear lah. Alright. Okay, kalau tengok, if you look at this figure, there's something that we call this idle Okay, idle So what the purpose of idle is to make sure that the driven gear later on akan mempunyai rotation yang sama. For example, that if you have these two set of gears, obviously, okay, katalah this is the driving ataupun the torque is inserted here. This is the driven. Okay, obviously it has a opposite direction at the end of the day. Tapi bila masukkan idle ni, dia akan boleh maintain the orientation on the final gear. So kalau awak insert sini, so it will rotation the other way around and it will follow basically back on the driving. So itu guna idle. Okay. Alright. So we have the input ataupun kalau awak tengok dalam text kita panggil dia driving. Okay. Ataupun driving, sorry tulisan buruk. Ya, saya gunakan pen sekejap Ya. Okay, yang ni kita panggil dia usually output ataupun driven. Okay, ini terms awak. So it means that it receive the torque or the power from the driving. Okay, saya tulis siap-siap. Sebab akan jumpa lagi benda ni. Alright. Okay, apa lagi sini? Okay, we call it as gear set. Yalah, betul lah. Gear set lah kan. Kalau the two of gear, we call it gear set lah. Alright. Right tadi tu yang tadi saya cerita tentang instead of bentuk cylindrical, dia dah dibentangkan kan. One straight line Itu right lah. Okay, tak ada apalah kot. Okay. So, yang penting sekarang ni idle lah. So, you know the function of the idle itself. Okay. Next. Okay, fundamental law of gearing. Okay. So, this is basically the formula that been defined by using the conjugate action tadi kan. Okay, the conjugate, we call it as the conjugate. Alright. So apa yang penting adalah about this the angular velocity ratio, okay, between the gears and gear set must remain constant throughout the mesh. So M usually is a constant Tekan music. Kan, and okay, other things is about the positive negative ni. It just to show you the sebenarnya kan dia nak tahu pasal orientation saja about the rotation sama ada in the clockwise or in the counterclockwise. If you look at this statement okay. Alright, itu maksudlah. Internal gear set has the same direction of rotation input and output. Kalau ada same rotation, biasanya kita ada positive side lah. Kan? Kalau macam this gear, confirm lah one is positive, one is negative. That to show you the direction lah. So I think tak ada masalah sangat lah kot about this. Macam ni, this internal set ni, biasanya sebab if you this direction pusing, yang ni pun pusing the same direction. Tak ada issue lah. Yang ni lain. Ini external set, this is internal set. Okay. Type of gear juga lah. Alright, this is the formula that awak akan gunakan Omega dengan radius dan juga number of teeth. Okay. Ni awak kena, paling penting formula yang awak nak kena tahu. Alright. So, apa soal lagi? Okay, ini awak nak Afdi ada lagi yang awak kena. Okay, dia ada banyak dia ada term MG, MA. Actually, basically the same Alright. Biasanya kita kena MG because refer to the when specifying gear trains. Alright. So M ni is a ratio Tak kisahlah ratio in term of what? In term of speed or in term of gear But dia ada relationship kat situ macam saya tadi lah. Kalau awak nak if you want a speed, mean that the driven gear must be have a lower radius, something like that. So the most important equation yang saya rasa yang awak nak kena adalah about the before that, alright, kalau awak tengok kat sini kan, awak tengok ada pinion 2 and gear 3. Okay, this is about the naming of the gears Biasanya if you look at this text ataupun mana-mana the gear is not starting from the number 1. There's no such thing gear number 1. Tak ada So the gear is actually starting from number 2. Number 2 and up to, tak kisahlah, up to bila-bila lah, and 6 ke whatever it is. So it will start number 2 and bila-bila lah kalau what is the number of gear, tapi dia takkan start from number 1. So katakanlah awak ada 3 gear, you have to start from number 2. This is the driving. This is the driven. See, this is gear number and 2, 3 and 4. Okay? Boleh faham So, very straightforward. Okay? Lagi apa Itulah maksud dekat sini. So you have to remember that biasa kita guna adalah number of teeth ya. N besar adalah number of teeth, N kecil adalah RPM ataupun rotation per minute. Okay, kena biasakanlah dengan terms ni ya. Alright. Okay, apa lagi yang saya nak terangkan? Okay, tak apa. Kita go to the next slide. Okay. Driven gear speed. Okay, alright. The formula that you need to understand is about, okay, saya bagi satu contoh macam mana nak tahu the speed of gear. Katakanlah awak ada gear pinion, we have the gear paling besar, okay, alright. Okay, so what you do have is the formula is something like this, and kecil, okay, katakanlah this is the number 2, this is gear number 3, so usually N3 divide N2 equals to N besar 2 divide di N capital N3. So this is the formula. Alright. So this is the formula lah. I think you need. Alamak, my battery is running out. Just a moment. Okay, my son. my smallest children tutup ni tutup saya punya laptop. Alright. Okay. Alright, this is the formula So tak kisahlah berapa banyak gear yang awak nak berapa banyak gear set yang awak ada. Katalah awak ada 5, 2, 3, 4. The formula kat sini biasanya kita akan start from katalah 2, sini 4 kan. So the formula should be like this. N3 N4. Alamak, sorry. Saya discard sekejap. Oh. Okay. Sorry. Okay. So macam saya tadi kita ada, katalah awak ada 2 set of gear. Oh. Tak keluar lah pula. Sekejap just a moment. Okay, alright. So we have the formula involved is basically simple je sebenarnya. So and katalah this is the 2, 3. Okay. Sorry, yes.
Slide tak nampak.
Tak nampak?
Tak nampak slide.
Okay, sorry. Okay, did you tak nampak ke? Saya dah project. Okay. Oh, dia dah tak nampak Sorry, saya kena project balik. Just a moment. Luckily you are around. Just a moment. Okay. Alright. Oh, okay. Akhirnya, finally. Sorry Asal dia terkeluar sekejap Saya pelik Saya cuba project balik. Okay, nampak tak? Nampak. Okay, that's fine. Okay, good. So this is the formula yang kita guna Alright. So maksudnya awak nak cari N3. Alamak, kenapa tak boleh conteng? Aduh, sekejap Okay, good. So N3 bagi dengan N2 sama dengan N besar 2. Dia selalu berkadang songsang kan? Macam saya cakap tadi pasal basikal tu kan. So nak tahu dia punya the speed of the N3, awak darab lah dengan padam ni, darab dengan N2. Okay. So sama juga a lot of the gears. Okay, the formulas would be the N6 macam ni kan. Awak berapa gear? You have 2, 3, 4, 5, 6. So awak bagi dengan dia punya formula lah N6 bagi dengan N2. Macam tu je. Awak ambil yang first and the last. Cuma dalam ni akan awak kena bijak sikit lah. Okay, awak akan tengok. Okay, negatif ni maksudnya dia punya the last ni. Rotation dia dah tak sama dengan ni, dengan yang ni kan. So that's why dia become negatif. So macam biasa awak dah ada. So dia punya formula kalau yang ni adalah base pada N2, N3. That's why awak bagi N2 dengan N3. Betul tak? Betul tak Sebab ni kan asal dia kan N2. Kalau kita bawa sini ke sini tadi, saya padam ni jap. Padam. So N6 N2 is N2 bagi dengan N3, which is the reaction between these two gear set. And also N3 and N4. You can say that dia mesti ada sequence kat sini. Ada N2, N3, N3 dengan N4 kan. Alright. So you will get this ni lah formula. Cuma dalam case ni, okay, satu benda yang awak kena highlight is about this N4 and N5. Okay, gear, awak kata gear katalah gear 3 dengan gear 4 ni sebenarnya they have the same speed, which is the N kan. Betul tak? Betul tak? They are in the same shaft. So that's why kat sini dia hilang. M4 tak ada kat sini. Kan dia terus jump kepada N5 kan. Di sini sampai N3, N4, N5 pun tak ada kat sini sebab dia dah, because they have the same rotation ataupun N besar, N kecil tu sama. That's why
kalau dia apa tu dalam shaft sama, dia apa tu N5 boleh represent N4
N5 represent N4. Yes, lebih kurang lah. Yes, sebab benda yang they are turn at the same speed.
Shaft.
Yes.
Okay.
Kan? Okay, katalah saya buat ni kan, saya buat 3, buat formula kita buat formula. Alamak, kenapa keluar ni? Okay. Okay, katalah this is gear 2, gear 3, gear 4. So basically N4 bagi dengan N2, betul tak? Okay. So kita start daripada N besar kan? N2 bagi dengan N3 times dengan N3 bagi dengan N4. Dia ada sequence kan? 2, 3, 3, 4. Tapi dalam case ni awak tengok dia hilang kan? Dia tak ada. N5 tak ada kat bawah ni. Sebab apa? Dia ada because it has the same, same speed lah. Sebab it has dia ada terletak di atas the same cylinder lah. Apa tu? Shaft. Okay? Alright, boleh faham this is very straightforward. Sebab soalan pernah keluar yang dulu. Dia suruh buat cari what is the N2, what is the N4 punya speed. So, awak kena derive formula tu sendiri. Okay, based on understanding lah. Alright. Itu kata awak tengok sini, no ratio between N and 5 because the gear are attached to each other. So, alright. So, the last one is about the train value, yang something important yang I have to explain. Okay, sebenarnya train value is a ratio sebenarnya. Ratio antara E ni. Okay, E adalah sama dengan driving tooth. Okay, number of teeth lah kan, betul tak? Maksudnya driving N2 bagi dengan driven kan. N3 kan, driven. Ini formula yang awak nak kena. So, this is the formula yang awak nak kena tahu lah. Ataupun L ni maksudnya adalah apa dia? Initial lah. Ataupun this is a final. F ni final lah maksudnya. This is the initial. Exactly. Alright. Okay. So, this formula is derived from this formula lah. Sebenarnya basically. So, awak tengok sini. Okay. E and final kan. E darab dengan S sebab kalau masuk sini dia akan darab dengan N3 kan. Sama je. So itu je lah. Ini okay. Okay, kalau awak tengok the last point ni, the last sentence kat here ni, okay, this is design code untuk gear. Alright, awak follow je. Awak kena ingat, awak sebagai engineer bukan awak design gear. Biasanya awak kena select the gear. Saya pandang balik supaya tak nampak mess on the slide. Alright. Okay, dah. Alright. Pen. Okay. Awak tengok sini. Kalau is the trend ataupun E value 10 to 1. Kan? 10 to 1. Okay. You can have a pair of gear. Maksudnya dua set of gear lah. Kan? Tapi kalau is more than 10. Okay. 100. Maksudnya katalah dia punya E dia from katalah E dia 1 lebih kecil ataupun 10, awak gunakan you have to use one pair of gear, ataupun if the equals to 10 lebih besar ataupun lower than 100, you going to use a two-stage compound design train. Okay, alright. So this is design code Okay, this is design code. Awak kena follow aje. Kan? Kenapa pakai two stage compound gear train? Jangan, tak perlu cerita lah kot Okay, so what is a two stage compound gear train? Kita tengok into the next slide. Inilah dia. Maksud dia, okay, the two stage compound gear ni, train ni, maksud dia adalah disebabkan ini. Okay, yang ni lah. Dia ada 4 set of gear sebenarnya. Tu maksudnya two stage maksudnya this is the first stage. This is the second stage. Okay. Kenapa? Okay, saya ceritalah kenapa saya kata kena pakai two stage compound gear ni. Saya rasa the reason behind it because katakanlah dia punya E dia terlalu besar. The issue is mungkin satu gear kecil, satu gear terlalu besar. Okay. Kalau based on my understanding lah Satu kecil, kita tak nak. Kalau kita buat macam ni, maksudnya dia dah tak efficient. So kadang-kadang that's why we have to go to the two stage compound gear. Okay, sebab that's why kalau awak tengok, katalah awak nampak this kind of gear, later on awak tahulah it's a two stage compound gear lah. Alright. So kalau tengok di side sini, this is the bearing place bearing. So nanti bila awak ada awak design gear, so you should put gear, bearing lah kat sini. This is for untuk shaft punya bearing Alright. Okay. So my question is, do you have any thrust load here? Jawapannya ada because of this. Ni kan teeth dia kan, dia dah incline. So saya tak pasti belah mana. Probably kita lah belah sini. Dia ada kat sini lah ada thrust load. Okay, dia ada thrust load nanti. Alright. So this is two stage compound gear Alright. So boleh faham Okay. Kalau tak ada issue, kita go to the next slide. Okay, dia satu lagi gear set which is not include in this slide. We call it as the kita panggil dia sebagai Okay, saya lupa dah nama gear dia. Kalau awak tengok buku teks awak if you turn your textbook on the page on the page saya satu lagi kita panggil dia compound reverted gear train which is on the figure 13-29 page 693 kat situ. Okay, ada dua type of gear Pertama, we have a two stage compound gear train which is dalam gambar ni. Yang kedua adalah a compound reverted gear train which is on the page 693 figure 13-29. Okay, tak apa. Nanti kita tengok soalan dia berkaitan dengan ni Alright. So, let's have a look on the example Alright. Kita tengok example, the next slide. Example 13.3. Okay. Hopefully you can bear with me. Alright. So, saya bacakan soalan dia for you guys. Alright. So, the question is a gearbox is needed to provide 30 to 1. Sorry, kalau tak keluar lah pula pen. Okay. Okay, to provide 30 to 1 increase in speed. Okay, maksudnya the final driven tu katalah speed dia, katalah dia the given speed dia 30 rpm, the final probably higher than 30. Okay, itu maksudlah. While minimizing overall gearbox size, specify operative number. So the question is, you want you to determine the number of teeth. Okay, macam mana nak buat soalan ni kalau terkeluar? Alright. So the first thing awak kena extract lah information daripada soalan. Dia kata to provide 30 to 1. Increase in speed. Apa maksudnya? This is the E lah kan? E. Okay. So awak tengok E kat, awak patah balik pada slide yang sebelum ni, previous slide, then you say that the problem with this kind of equation is, you know, you cannot use the one pair of gear, but instead you have to use the two-stage compound of gear train. Okay? Alright. Okay, itu soalan. Alright. Okay, so maksudnya awak kena lukis lah. Lukis two-stage of gear train. Okay. Okay, macam ni. Alamak, sekejap saya padam sekejap. Okay. Mana saya punya? Okay. Tak keluar pula. Okay, maksudnya sinilah kan. This is katalah gear first. Okay, saya buatlah. Tak cantik lah tulisan saya punya ni. Ya, saya padam balik. Tak cantik sangatlah saya punya lukisan. Okay. Okay, sekejap Alright. Okay. Okay, this is the another gear. Tak kisahlah. This is the gear. So this is the shaft. Okay. This is the shaft. Saya lukis balik. Hopefully you can. This is the gear, the shaft and the gear. Okay, this is a two-stage compound gear. Alright. So, E ni sebenarnya kalau awak tengok, dia kata 30 betul tak? So, the overall E untuk semua ni adalah 30. Okay. But, you can divide it into 2. So, kat mana yang first E? This is the E1. Okay. Okay, saya buat macam ni. This is the E1. This is the E2. Okay. Alright. So, ke sini ada E tak? Tak ada sebab they are at the same shaft. Dia tak ada E. So, sebenarnya E ni sebenarnya dia base pada ni kan. E ni, E dengan 2 ni. So, sebenarnya 30 ni adalah E kuasa 2 sebenarnya. Kenapa E kuasa 2? Sebab kita assume they have the similar E lah. Okay, that's why awak tengok sini, dia bagi set 30. So, nak tahu E1, kita kena bagi ataupun punca kuasa 30, which is the 5.4472. Okay, so maksudnya sini adalah 54772 dan benda ni samalah E1 E2. So nanti bila awak darab balik, awak dapat ni darab dengan kuasa 2, nanti awak dapat balik yang 30 kan? Betul tak? Alright. Okay, next. Apa lagi information yang awak nak kena tahu ialah awak gunakan 20 pressure angle. Kan? So this is normal lah gear kita pakai. Alright. So the other information that awak nak kena tahu is the number of teeth. Okay. Gear ni you cannot simply put number of teeth dia 13. Tak boleh. Sebenarnya the minimum size of the gear is actually 16. Kalau awak gunakan 20 pressure angle biasanya. 16 is the minimum of number teeth that you can apply. Kalau awak 13 ataupun kecil daripada 13 ni, kemungkinan akan berlaku interference. Okay, interference. So tak sesuai lah. Kita nak conjugate action, betul tak? So kita tak nak ada interference. So nak tahu macam mana dapat 16 ni, awak kena refer pada textbook lah. Saya tengok kalau I'm taking my textbook, if you look at the sekejap if you look at this kalau awak tengok pada interference tu chapter interference tu, okay, awak refer pada equation 13/12. Okay, equation stroke 12 tu dia akan ceritakan kenapa kita kena pakai 16. So 16 actually is the minimum untuk mengelakkan interference. Okay, so maksudnya satu gear awak tahu dah kan. So minimum teeth yang kena ada adalah 16. So awak kena tahu what is the value teeth the second gear. Now the question is, macam mana awak nak tahu which one is the, contoh you have the N2, N3, N4, N5. Okay. So salah satu dua daripada gear ni sebenarnya you have dah dapat answer lah. Kan dia dapat 16 kan. Satu lagi tu macam mana nak tahu? Alright. Tengok boleh lah mana, kalau nak tahu kat mana driven, kat mana dia punya Kat mana formula tadi lah, E sama dengan apa tadi? E sama dengan N driving bagi dengan driven betul tak? So itulah, so kalau katalah awak assume this is the driven ataupun driving, kan, confirm lah sini adalah driven kan. Okay, alright, so that's happening lah. That's why awak last kali awak masukkan 16 darab dengan set 30 tadi, you can get 88. Awak dapat 87.64. So obviously that mana ada gigi 87.64. So awak kena bundarkan menjadi 88. Okay, boleh faham tak kat situ? Okay, satu lagi isu yang awak nak kena, you have to look is about the percent. Dia ada error. 1% of the tolerance. Kategori ada tolerance lah. Okay, nak tahu jawapan awak betul tak betul, you have to darab balik, dapatkan the total of the E, which is 88 bagi 16. Awak darab balik dengan 88 bagi 16, dapat tak dengan sama dengan 30.25 kan? Awak dapat 30.25, which is bila awak calculate balik, is actually below 1% of the tolerance. So maksudnya calculation awak tepat. Okay, kenapa berlakunya tolerance ni? Sebab apa? Sebab thief tadi ni. So the question is, boleh tak awak ambil 87 thief? Jawapannya boleh. Kan, sebab untuk dapatkan E30 ni, you need to have thief 87.64, but that is not, doesn't make any sense, betul tak? So you either to sell 88 ataupun 87 basically. So kalau 87, probably that awak mungkin dapat 29 kot. So 29.8 kan. So still within the 1% of the tolerance. Okay, soalan ni ada soalan tak? Ke awak nak buat dulu?
Tengah digest.
Tengah digest. Okay, ada tak faham tak? Kat mana yang tak faham? Okay, saya patah balik. Okay, saya patah ni rajah cantik lagi lah kot. Mana yang saya lukis tadi. Alright. Saya erase balik. Okay, saya erase balik semua. Okay, soalan sama je dengan ni. Alright. Okay, soalan tu dia kata dia nak tahu what is the gear size. Okay, so obviously, okay, based on the information, okay, so this is part. Okay, this is part. Okay, alamak, lari lah pula. Alright. Okay, sekejap saya padam balik. Alright. Okay, kita baca soalan balik. Okay, dia kata a gearbox need to provide. Saya padam semua balik. Okay. Saya terangkan balik again. Okay, a gearbox is needed to provide, okay, 30 to 1 increase in speed. Okay, you can imagine that kalau dia kata increase in speed kan, saya bagi idea kalau increase in speed, biasanya kan gear belakang yang kedua tu mesti kecil lagi. Alright, betul tak? Sebab kalau increase speed biasanya kalau awak kan berkadang songsang kan, kalau speed tinggi kan, mesti radius dia ataupun dia punya diameter jadi rendah. Okay, itulah dia punya orang kata insight kat situ. Alright, cuma dia ada bagi addition about 1% of the orang kata error, bukan error lah, I mean tolerance, while minimizing the overall gearbox size. Specify appropriate number of T. So information awak tahu, awak perlukan 30, which is you need a what call it, 2-stage compound gear. Okay, dan untuk elakkan interference, the number of T minimum adalah 16. Okay, the question ni you tak tahu which gear is it. Maybe gear, maybe gear 2, gear 3 ataupun gear 4 ataupun gear 5 kan, you tak tahu. So dah tahu dah kan. So in that case, the way we to do it, saya pergi ke sini. Okay, alright. So kita tahu kita ada 2 compound stage. Okay, E sebenarnya, E tu adalah untuk compound stage adalah E yang ni, yang first stage ni darab dengan E ni. So sebenarnya adalah dapat dengan total number of E, which is 30. Okay, bila nampak This is the E1, this is the E2. So the Okay, since that kita tak tahu sebenarnya, kita tak tahu what is the exactly number of T, cuma dia bagi tahu then the minimum of T is 16. Alright, so by using that, kita gunakan, kita setkan dia 30, we got the 5.447 lebih kurang. So this is a ratio that between this dengan yang this dengan this. Okay, alright, itu assumption kita yang paling mudah. Dan you masuklah formula tadi E ni tu. E sama dengan apa tadi? E sama dengan driving tooth member bagi dengan driven. Kan? So katalah this is N2, this is N3, this is N4, this is N5 So dia kata tadi driving. So driving is convert lah daripada atas kan, ataupun daripada bawah lah, tapi saya ambil daripada atas lah sebab small number kan. So N2 bagi dengan N3 kan? Betul tak? Betul tak? E tu. Okay, driving tu bagi driven. Okay, betul dah? So masuk je lah 5.447 tadi darab dengan 5.447 tadi darab dengan berapa? 16. Okay, the question is kenapa saya kata 16? Kenapa kita darab 16? Macam nak tahu which one is number 2, which one number 3? Confirm lah this is the driving kan? This is the driving, this is the driven. Kan? Kenapa kita darab dengan 16? Kenapa kita anggap N3 ni sebagai 16? Kenapa? Sebab kalau awak tengok make sense cakap tadi kan, kalau increase in speed, mesti yang belakang tu jadi kecil. Katakanlah decrease in speed, mesti belakang lagi besar. So that's why saya dapat anggap bahawa N2 ni sebenarnya sepatutnya lebih besar daripada N3. So saya darab lah. So dapatlah tadi, awak dapat tadi kat sini awak dapatlah 88. Okey, tapi sebenarnya 87 lah, tapi kita mundarkan kepada 88 ataupun 87 pun boleh juga sebenarnya. Okey. Alright. So, sekarang ni okey. Awak boleh check untuk yang E kedua pula sama je. Kan? Betul tak? Sebab apa? Kita anggap the E1 dengan E2 tu benda yang sama kan? Sebab the value is the same. E1 is 5.447. Yang E2 pun 5.47. So, kita boleh assume lah yang it is the same number of teeth. And kita tahu bahawa dia dah bagi tahu kan 16 kan minimum kan. So yang tu pun formula yang sama, dan you will get the ni lah maksudnya N2 is 88 sama dengan N4 lah. So N3 sama dengan 16. 16 okay, N5 juga sama dengan 16. Alright, so awak check balik E tu 88 bagi 16 kan, darab dengan E1 kan, E1 darab dengan E2 you got 30.25. Kenapa ada tak dapat 30? Sebab kita dah TIF tu kita dah bundarkan pada yang terdekat. That's why you got 30.25. Awak check lah 30.25 ni adakah dalam tolerance kan, darab dengan 100 kan, adakah dia lebih daripada 1%? Kalau dapat less than 1%, betul lah. Kalau awak dapat above 1%, it's not right lah anymore. Okay, boleh faham tak kat situ?
Boleh lah.
Boleh faham tak kat situ? Aduh, dia kata this is technical very technical. Tak apa, awak tak faham tak apa. Saya tak akan pergi, saya akan my example akan stop sampai 13.4 je lah kot Sampai sini je sebab almost 12. Okay, sebelum awak jadi gila, baik saya stop 13.4. Alright. Okay, awak tengok soalan 13.4 ni. Okay, soalan dia kata apa? A gearbox is needed to provide exact 31 kan? Still increase in speed while minimizing the overall gearbox size. Specify appropriate number of teeth. Okay, apa maksud beza dengan soalan tadi? Dia ada exact. Okay, dia ada exact. Apa maksud exact ni? Maksudnya bila awak check nanti later on, kena 30 juga. Tak boleh 3.25. Okay. So, this is a condition awak nak kena meet. Tapi bila tengok balik, dia punya type of gears ataupun configuration of gear is the same. Awak kena pakai a two-stage compound gear. Okay, jom kita buat yang ni. Alright. Saya padang balik. Alright. Saya padang balik. Supaya awak nampak balik. Okay. Alright. Okay. Kita tengok soalan balik. Okay, untuk yang ni kan, oleh kerana dia perlukan orang kata exact E tu. Okay. Alright. Okay. Awak dah tak boleh gunakan punca kuasa 2. Sebab bila awak gunakan punca kuasa 2, nanti awak akan dapat ni lah. Ni kan, 16 darab dengan awak dah kan, awak dapat perpuluhan, betul tak? Sekejap saya padam balik. We erase. Okay. Kita tak nak nanti untuk ni sebab dia kata exact. Kita tak nak gunakan, kita tak assume dia dah sama lah. Okay. Maksudnya kalau awak put set 30, awak dapat 35.4, confirm awak akan dapat, obviously awak akan dapat a value perpuluhan. Sini kan. So kalau kita katakanlah what call it, katakanlah 3 darab dengan 15, awak tak akan dapat perpuluhan, betul tak, number of gear tu. So tu sebabnya dia ada error kat sini. Okay. Okay, untuk soalan ini, okay. Okay. Untuk combination macam saya tadi lah, kita ada first stage. Kan? Kita ada so kita ada first stage E1, okay, which is this one. We have the E2. Kita tahu bahawa the total is actually E1 darab dengan E2, betul tak? So, combination yang possible adalah 1 darab dengan 15. Kan, betul? We got 30. Okay. Katalah this is the E1, this is the E2. So, bila awak buat combination lain, 2 darab dengan berapa? 1 darab 30 Okay, 2 darab dengan 15, which is 30. So, 3. Boleh dapat tak? 3 darab dengan 10. You still got 30. Lagi apa? Combination boleh dapat 30. Kalau 4 boleh dapat tak? Tak dapat kan? 4 darab dengan, tak dapat kan? Kita tak dapat
5 darab 6.
5 darab 6. Darab dengan 4, 30. Dia se-close tu, Pak. 7 boleh dapat tak? 7 darab apa boleh dapat tak? Tak dapat kan? 8? 8 darab 5 lah. 8 darab 40 kan?
Tak, 40.
Kan? Ada lagi tak combination boleh dapat? Tak ada kan? Saya rasa dia is a 5 darab 6 je lah. Okay? So 5 darab 6, lepas tu awak boleh buat 10 darab 3, betul tak? Kan? So supaya E1, E2. So the possible, okay, dalam case ni, the most appropriate adalah 5 darab 6 lah. So kita boleh katakan E1 is 5, E2 is 6. Okay, kenapa kita kena ambil the close 5 darab 6, kenapa bukan 2 darab 15, 1 darab 30? Nanti kita tunjuk dia punya calculation dia. Kenapa kita tak gunakan? Because kalau kita gunakan combination yang terlalu jauh, contoh 2 darab 15 ni, kemungkinan salah satu gear ni mungkin terlalu besar. Sebab terlalu besar. Contohkanlah gear ni 20. Yang satu lagi tu mungkin jadi 400 gigi. Kita tak nak ni. Okay? Alright? Kita tak nak. So that's why kita ambil combination the nearest by 5 darab dengan 6, which is equals to 30. So we're not going to take 2 darab 15. Kita tak nak supaya terlalu besar gear ratio. Sebab apa? Soalan dia kata minimizing the overall gearbox. Okay. Kalau tak ada ni, lantaklah awak nak pilih nombor 1 Awak nak pilih 1 darab 10 ke darab 30 ke, it's the same. Okay. So, bila awak dapat tu, that's why the example here, dia kata 5 darab 6. So, awak masukkan formula balik, you got N2 bagi N3 darab dengan 6, N4 darab dengan 5, then you know that the number of gear to avoid interference is 16. Kena more than 16. So, kita tahulah salah satu gear dia. Okay. Alright. So, awak selesaikan lah. Ini dapat dah. Ni dapat dah. Kan? So, sekarang ni, nombor satu gear is kan? Kita tak tahu which one gear is 60, which one gear is anti. Tengoklah kat mana is driven ataupun driven lah kan? Betul tak? Betul tak? So, the driver is driven. Okay? Okay. So, sekarang ni kalau awak fikir balik, dia adalah increase in speed. Okay? Dan sepatutnya, kalau ikutkan, N3 ni supposed to be Lagi besar kan lagi kecil? Kan kalau dia increase speed patutnya lagi kecil daripada N2 lah. So 16 is valid on the N3 lah. Okay, so at the end of the day, bila awak dah masukkan value tersebut, N5 ni pun sama kan lah, 16 lah. Kan? Betul tak? So, you got 96, you got 80. N2 awak dapat 96, N4 you got 80. Okay? Okay, boleh faham kenapa macam tu. So, bila awak darab balik, awak gunakan 96 bagi dengan 16, darab dengan 96 bagi dengan 16, you will get exact 30. Itu yang berlaku kat bawah ni sekali. Okay, boleh faham? Okay, kita bagi condition. Kenapa saya kata tak boleh bagi, kita tak boleh gunakan condition 1 darab 10, kita buat calculation. Senang je. Alright. Saya padamkan balik. Okay, I will erase. Erase. Katakanlah awak gunakan, katakanlah you use 130 lah, 130 kan, ataupun 215 Katakanlah ini kan, saya padam, gunakan 1 darab dengan 30. Betul tak? So obviously sini 1, this is 30. So bila awak darab dengan N3 16, maksudnya equation awak nampak esok. Okay, 1, 1. Kan awak dapat 1 dari 16, you got 16. Okay, dia ada untuk N4, N5 ni awak, you got 30 kan? 30 times 16 berapa? Ada calculator tak? Somebody can give me a value. 30 darab 6 berapa? Which is, ada calculator kat saya. 13 times 16. It would be
480.
480. Tak make sense Awak kira lah berapa dia punya pitch diameter nanti. So maksudnya satu tu very kecil, satu lagi tu very big. Okay, boleh juga tak ada issue. Cuma sekarang ni awak tak memenuhi syarat, which is minimizing the overall gearbox size. That's why kita gunakan 5 darab 6 tadi lah, the nearest lah. Okay. Sebab the gear awak dapat apa very straightforward awak dapat 96 dengan 80 tadi kan kat sini. So tak dapat tepat perpuluhan kan. That's why bila awak darab balik, you will get the exact number. Okay, boleh faham? Boleh
Boleh.
Okay, boleh So straightforward. Okay. Kita pergi last. Yang terakhir. Alright, this is the terakhir lah for this today Saya tak nak lama panjang-panjang. Saya tak nak awak jadi gila. Okay. Alright. Yang gear Saya padam balik erase all those things. Okay, 13.6. Alright. So siapa tolong mute Okay. Alright, dia kata okay. So a gearbox is needed to provide an exact. Nampak tak? Masih lagi 30 Increase in speed while minimizing the overall gearbox size. The input, the output should be in line. Apa maksudnya? Ialah this is a riveted gears. So what is a riveted gears? Okay, maksud dia okay, saya go back to this this is a compound stage two stage compound. Riveted gear is gear inline maksudnya. This is the gear, the first adalah N2. This is the shaft. This is another gear. There's a shaft as well connecting to these other gears. Dan dia ada satu gigi kat sini. So beza dia tak ada apa je sebab dia kata inline. Yang ni input ataupun driving dengan driven should be inline. Ini kita panggil dia riveted gears lah basically. Alright. Kan? Okay. So nampak itu je beza dia. Tak ada apa We go to the example example 13.5. Okay. Alright. Okay, saya lukis balik. Harap cantik sikit lagi. Okay, gears. Okay. Okay, inilah compound dia. So E dia still the same lah kan? Still E dia masih lagi E1 dengan E2. Cuma dalam case ni, dia ada formula yang awak nak kena tahu This is the formula Okay, awak ikut je. Kenapa? Awak kena ikut je lah. Alright. So N2, N3 ni, macam mestilah E darab, 5 darab dengan kan? E1 darab dengan E2 should you get 30. So 6 times 5 equal 30. That's why N2, N5 mana-mana boleh kalau awak nak N2 bagi N3 5 pun boleh, awak nak bagi N4 divide by N5 6 pun boleh, tak ada issue. So dalam case ni assume that 6 5 Right, this is the formula and then awak solve the problem lah macam biasa. Sama je. Exactly yang tadi. Cuma the most important thing is the minimum to avoid interference. One of the gear you should use 16, the minimum size. Kan? Tapi katakanlah awak tak nak, awak kata awak nak guna 18. That is no issue. Asalkan jangan guna kurang daripada 16. Katalah awak kata, okey lah, awak nak guna 20 lah. Boleh je, tak ada issue pun. Cuma jawapan dia takkan sama lah dalam N4 takkan sama lah. Takkan dapat lagi lah dalam sama like in this example Okay, boleh nampak tak kat situ? Boleh nampak So you got the persamaan serentak nanti. Alright, bla 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 bla. Saya takkan buat, awak buat sendirilah. Alright. So the end of the day we got the answer kat sini. Nanti awak tengok balik. Alright. Okay, ada soalan? So, but the most important thing is yang paling if you want to check whether it's correct or not, you have to check dengan ni lah. Okay. Sekejap Sorry. Check balik. Adakah sama N2 plus N3 akan ikut N4 dengan N5 which is 126. So, that is the reverted compounded gear set. Boleh faham Alright, saya takkan buat sebab dah pukul berapa ni? 12. Okay. Boleh, so you have to study slightly lah, okay, dekat kat rumah esok. Alright. Okay, this is the most interesting part. Very technical, tapi saya takkan masuk hari ni. Okay. Boleh ke? Ke awak nak masuk juga? Because I'm planning to stop now. I'm planning to stop now because I don't want to make your head become, okay, damage ke whatever it is. Alright. So because the example after this is quite technical juga, alright. Okay. And tak banyak lah kot. I think after that, we go to the analysis of beaver gear. We do some example which is quite complicated juga lah, alright. And the last one kita pergi ke shaft. Apa dia?
Complicated betul tu sir.
Yes, memang. I have to say that gear is quite complicated. Tapi it's fun. Apa susah kan? Because that's open book, betul tak? Untung orang semua open book sekarang kan, bila saya check semua meniru kan. Betul tak? Alright, tapi lah saya takkan teruskan. Last sekali shaft lah. Shaft ni tak banyak. I think shaft ni tak ada apa saya nak tekankan, cuma some of the issue lah kot yang kena you highlight lah kat sini. Alright, so for next week I will stop now, okay. For next week kita akan go for the force analysis of the gear, okay. And we go to the shaft slightly, and we do some exercise lah. I have some questions from this textbook. Kita buat, alright. Make sure that you have the papers, calculator, and so on with you lah. Alright, so give you some time to do it. And if you don't understand, you can always ask me lah in the lecture. Okay, is it okay Alright Sekejap saya tengok attendance. Just a moment. I would like to look on the attendance. Okay, just a moment.
Sir.
Ya.
Yang dia tadi kan, dia punya calculation macam dynamic je sir? Ke memang cara
yang
sama
mana?
macam dynamic? Yang gear yang nak masuk minggu depan tu.
It's like dia ada
yang global dengan local kan?
Yes, dia ada vector sebenarnya. Alang ada vector. So never mind.
Macam susah je sir.
You kan awak kan open book. Alright. So tak apa, kejap, tak apa. Sekejap Saya nak cari what's attendance. Lama tak ada lah. Dia orang tak bagi saya attendance sekejap I'm looking for attendance punya link. Untuk hari Khamis sekejap Bear with me for a while. Saya lupa nak buat attendance. Thursday. Check let me have a look. Tuesday, yesterday. Alright. Check. Saya cari attendance last week. Mana attendance ni? Sekejap.
Sir, ni attendance dah ada orang share dekat
Dah.
tu?
Okay.
Kat chat.
Bagus. Dekat chat. Okay, thank you so much. Saya tak tengok tadi. Saya kena. Alright, thank you Shuhada. Okay, thank you so much. Okay, I think that's for today. Alright, so macam saya kata tadi lah, if you have any question, you can ask me. Okay, obviously lah, my class you can obviously kalau ada class tu you can ask your lecturers lah. I'm sure that they know about this. Okay, alright. So with that, that the ends of the class, and I wish you stay healthy lah. So don't okay. Jangan kena COVID lah pula salah nanti. Alright. So itu saja daripada saya, and Assalamualaikum warahmatullahi wabarakatuh. I will see you next week.
Thank you, sir.
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 Thank you, sir.